गुड मॉर्निंग मैम.
गुड मॉर्निंग बेटा. कौन बोल रहे हैं?
Rana Shehbaz, how are you, ma'am?
I'm fine. How are you?
Good morning, ma'am.
I'm good, perfectly fine, ma'am.
That's great. You look very alert. Right. That's nice. हाँ जी. Good morning बेटा. कौन बोल रहा है?
Abira, ma'am.
Abira. How are you, Abira?
I'm good, ma'am. How are you?
I'm fine. Thank you. Okay. और कौन है हमारे साथ? Hello चांद खुशी. Good morning. कौन बोल रहा है? नाम बोला करो please.
Zarish. Zarish, ma'am.
Okay. How are you, Zarish?
I'm fine. How are you?
I'm fine. Thank you. Yes. और
गुड
कौन?
मॉर्निंग मैम.
अब कौन बोल रहा है? नाम बोला करो प्लीज.
मैम चांद.
चांद. क्या हाल है चांद?
मैम आई एम फाइन. हाउ अबाउट यू?
आई एम फाइन. थैंक यू. ओके. और हमारे साथ इब्राहिम. हेलो इब्राहिम.
अस्सलाम वालेकुम मैम.
वालेकुम सलाम. हाउ आर यू?
आई एम फाइन मैम.
और कौन है यहाँ? फरीदुद्दीन. हेलो.
अस्सलाम वालेकुम मैम.
वालेकुम सलाम. हाउ आर यू?
I'm fine. How about you?
आई एम फाइन. थैंक यू. हेलो सनिया.
Good morning, ma'am.
गुड मॉर्निंग सनिया. यू साउंड सो स्लीपी.
No, ma'am. Up to you.
अच्छा. गुड. हेलो शेरल.
Good morning, ma'am.
Good morning. And who else do we have? Let's see. Hello, Moaz.
Good morning, ma'am.
Good morning. Okay, so let's start, right? Okay, I'm going to share my screen with you.
Assalamu alaikum, ma'am.
Walaikum salam. Who's that?
Suhaib Tahir.
Sohaib Tahir. How are you, Sohaib?
I'm fine, ma'am. How's ma'am?
मैं ठीक हूँ, thank you. Okay, so what were we talking about last time? We were talking about rotational motion, right? ठीक है? So when we talk about rotational motion, we know that we talk about quantities like torque, है ना? So what is torque? Torque क्या होता है?
Turning effective force.
Yes. So torque plays the same role in rotational motion as force does in linear motion. ठीक है ना? क्योंकि उसकी इक्वेशन क्या थी हमारे पास? The equation was torque is equal to
RF sin theta.
हाँ, RF sin theta. Okay, so it's a product of what is R? What is R? कौन बोला था अभी?
मैं सुहेब ताहिर.
Sohaib Tahir. What is R?
मैम माइंड नहीं हो रहा.
हैं?
माइंड नहीं हो रहा. क्या था?
अच्छा, कौन बताएगा? टॉर्क का सिंबल क्या है?
नैनोमीटर.
हाँ?
नैनोमीटर.
टॉर्क का सिंबल क्या है? What is the symbol for torque? किसको याद है?
मैं वो टी सा करके था कुछ.
ही नहीं है बेटा, इट्स द ग्रीक लेटर जिसको हम टॉ बोलते हैं.
ऐसे ही था.
ऐसे है ना? एंड इट डिपेंड्स अपॉन आर. आर क्या है? दिस इज कॉल्ड मोमेंट आर्म. नहीं, मोमेंट आर्म कहते हैं इसको. इसकी पर्टिकुलर, तुम्हें पता है साइंस में हर चीज का एक बड़ा स्पेसिफिक मीनिंग होता है, ठीक है ना? सो आर को हम रेडियस के लिए आमतौर पे यूज करते हैं, बट इन दिस केस, इन द केस ऑफ टॉर्क, इट्स डिफाइंड एज द मोमेंट आर्म, व्हिच इज डिफाइंड एज द perpendicular distance from the point of application of the force to the rotational axis. ठीक है? वो हमने r perpendicular यूं लिखा था ना, r perpendicular, तो वो sin theta इसलिए आता है ना. ठीक है? So यहाँ पे in rotational motion हम जो force, simple force use करते थे in linear motion and rotational motion, we use torque, which depends upon the moment arm and the force. But it also is important to understand the point of application of the force, the direction of application, and its distance from the rotational axis. I gave you the example of the door, है ना? So you can apply a small force to open it if you're applying it in the right direction and at the right point. But if you're applying a huge amount of force in the wrong direction at the wrong point, you will not be able to open the door. You understand the difference? समझ आ रही है? Hello?
Yes, ma'am, आ रही है.
हाँ, good. So try to understand कि rotational linear motion पहले हम पढ़ते थे. Linear motion is a motion along a straight line. Rotational motion is a motion in which a rotation is taking place around an axis. Example of a rotational motion, we discussed different examples last time. For example, the top, the small top that children play with is a very good example of rotational motion, है ना? Because it rotates around an axis of rotation. You see, children find it fascinating, and in fact, this is also a concept of physics. ठीक है ना? So this is a concept that's applicable in sports. It's applicable in dance. It's applicable in the universe also. You know, the Earth is also rotating, right? These planets and the moons and all these bodies are rotating. It's applicable on the highest level if you talk about cosmology, universe, astronomy, and it's also applicable at the smallest level if you talk about small particles like electrons, for example. They are also rotating. They're also undergoing a motion. So therefore, rotational motion is a very important kind of motion, right? वैसे भी if you look at your bicycle, for example, your bicycle wheel like this also undergoes rotational motion. Okay, so it's very relevant. ठीक है? Whether you're riding a bicycle or whether it's a car, you know, the wheel is also turning around. So that's also an example of a rotational motion. So therefore, now we will talk about the fact that rolling, for example, a ball rolling on a surface, or a wheel, you know, the wheel of your bicycle or your car is a combination of translation and rotation combined. Okay, so what is translation? Translation means in this case, translation in the case of motion means it's translation plus rotation. Okay, so what is translation? Yes. Translation means? Nobody knows. Okay, translation means going from point A to point B. Okay, this is translation. You're covering a linear distance. Okay, and rotation means the wheel is also turning around its axis. So the motion of your bicycle wheel or your car wheel will be a combination of going from point A to point B. It will cover a linear distance as well as it will be covering the rotational distance with displacement, which we represented by theta last time. So it will be a combination of linear as well as rotational motion. Is that clear? समझ आ रही है?
Yes, ma'am.
Good. Okay, so now, you see, we started with a very simple example of motion in chapter 2, 3, 4, right? And now we included the rotational aspect, and now we're combining both the translational motion and rotational motion, which is translational motion was the simple motion you were studying previously, and rotational motion was the motion we studied in the last chapter, and now we're combining both, okay? Because actual everyday motion consists of both. The example is the bicycle wheel or the car wheel, right? Okay, so if we have this wheel, we know that it is rotating about an axis which is at the point O, and therefore the center of mass will be at the point O. We talked about the center of mass previously, right? So the center of mass is also important, and this will also move a distance as a translational distance, a linear distance from one point to another point. So if we consider one point on the wheel, which is P, let us take one point P. Like we said, every body is composed of a system of particles. So in the beginning chapters, we considered the simplest case in which we were considering a body to be one particle and we applied the formulas. But then we know in reality, a body is not one particle, it's a system of particles, it's a combination of particles. So therefore, we came to the concept of center of mass. And therefore, the velocity of this point will be the velocity of the center of mass, okay, where the whole mass of the body is concentrated, right? And then we are now talking about a point P, which shows a random point on the surface of the wheel, because we know that when a body moves in a circle, it covers a rotational displacement, which is theta, and S is the arc length, okay? So this arc length can be represented like this, and it can also be represented like this. Okay, you can see this red part that's highlighted here. This is the arc length S. So you can also represent it like this and like this. So now you can see that the center of mass O of a rolling wheel moves a distance S at a velocity v com. V com is the velocity of the center of mass, while the wheel is rotating through an angle theta. So we are now understanding motion as a combination of translational and rotational motion. Okay, now the word translational is clear, right? The point P is the point at which the wheel is touching the surface, okay, of the road or wherever you're going. And therefore, this is the point that will go from point A to point B, and it will cover a distance S, which is equal to the arc length we talked about, S R theta. You know, we talked about these quantities last time. So this is the equation where S is the arc length, theta is the circular displacement or rotational displacement, angular displacement, it's also called the angular displacement, and R was the radius of the circular path. In this case, it's the radius of the wheel. And V is the linear speed.
R smaller नहीं था, इसमें कैपिटल है.
वो तो एक स्पेसिफिक एग्जांपल ले लिया ना, वो जनरल फॉर्मूला लिखा था पहले, ठीक है ना, एक सर्कल बना के उसमें हमने आर उसका रेडियस बताया था. यहाँ पे वी हैव टेकन द एग्जांपल ऑफ अ व्हील, एंड यहाँ पे उसका रेडियस जो है उसको हमने डिफाइन किया है कैपिटल आर के साथ, ठीक है.
ओके मैम.
वही देखो, ये व्हील का रेडियस है, ये देखो, ठीक हो गया. ओके, एंड फिर हमने ये भी बताया था कि लीनियर वेलोसिटी एंड एंगुलर वेलोसिटी आर रिलेटेड बाय द रिलेशन v is equal to omega r. Again, you multiply the angular velocity by the radius of the body and you get the linear velocity, and this motion is called a smooth rolling motion. Okay, आपका wheel roll करता है तो you cover both translational displacement as well as angular displacement. ठीक हो गया. Okay, so यहाँ पे we see this figure again, the same wheel. We see the angular velocity omega. We see the point P with the velocity v com. We see that in the first case, in figure A, we are only looking at pure rotational motion. Okay, the spinning of the wheel, the going of the wheel round and round. In the second, we've broken up this motion in figure 11.3 to its component motions, which was rotation plus translation. Translation means the point P is covering a distance on the in a translational way from point A to point P. So in that case, we call this translation, and rotation plus translation will be equal to rolling motion, and therefore we can combine this and then we can write the equations for this. Okay. Oh, okay. Now we can see the different ways that when it is rolling, how the velocity at the different points will change. When we talked about circular motion, we also talked about this. So the direction of the velocity is always tangential. Tangential means perpendicular at a point to the radius. Now, kinetic energy again was a concept we studied. We started studying kinetic energy for linear motion, which was half mv squared. Then we talked about rotational motion, and we said that instead of mass, we have to write what? Capital I. Capital I was the moment of inertia. So we also defined the formula. There was a table in the last chapter in which we said that I depends also on the shape of the body. For example, the value of formula for I for a sphere is different for the formula for I for a cylinder, for example. And therefore you write that, and if you need the formula, you can look it in the table. And then instead of v, we write the angular velocity, which is omega squared. So this is what the formula comes out to be. So kinetic energy for rotational motion, kinetic energy for translational motion. And then we can also write from the theorem that we studied there that the rotational inertia is a combination of the rotational inertia of the center of mass plus mr squared. So we discussed this in the last chapter, right? So we can write this instead of IP, we can write this, okay. We can substitute this value of IP, and then we can write the kinetic energy as a combination of these two terms, okay. So therefore, you have the definition here. A rolling object has two types of kinetic energy. A rotational kinetic energy, which is this, due to its rotational motion about its center of mass, and a translational kinetic energy, which is the common one, half mv squared, due to translation of center of mass. Okay. So this is the one that we were studying in the beginning, which was translational motion or linear motion. And now this is the one which is due to the rotational motion. And the total kinetic energy is the sum of these two. Okay? Okay? Yes? Bola karo.
Yes, ma'am.
Good. Okay. So we also know from the beginning of this course that whenever you want to have any kind of motion, you have to apply a force. So similarly, when you want to have a rolling motion, like the motion of a wheel, you have to apply a force. But then another concept we came across was the fact that whenever we apply a force on a body, there's a friction as well. There's a possibility of having a friction, right? Now, if the body is rolling at a constant speed, then we will say that there is no frictional force. Okay? But if the speed of the body is changing, it is because there is some force, and that will produce a certain acceleration. Okay? Now, there are two types of friction we talked about. We talked about static friction, which is Fs. So if the wheel does not slide, the force is static frictional force, and the motion is smooth rolling motion. Okay? So in that case, we can write the equation A is equal to alpha R. Again, this is an equation we studied in the last chapter as well. Okay. Now, when the body starts moving, if the wheel does slide, when the net force acts on it, then the frictional force acting will be the kinetic frictional force. You know that we have two kinds of frictional force. So in the first case, when the speed was constant, there was no frictional force. Okay. In the second case, when the body was not sliding, but you were applying a force, it means there was a static frictional force, and therefore this leads to an acceleration. And in the third case, when the wheel starts sliding, then you have a kinetic frictional force. We've already studied these forces in the previous chapters. You've also given the quiz with this topic. Okay. Right. Now, another kind of motion. Now, most of the time we're talking about a body moving on a horizontal road or a straight road or on a flat surface. But then we can go to the next step where we were talking about an inclined plane. An inclined plane means a surface which is making a certain angle with the horizontal. Okay. So in this case, we can call it an inclined plane, or we can call it a ramp. You know that many a times you have to travel on a ramp, even in front of your house, in front of your garage, you have a ramp like structure. And your car, when you take it into your garage, for example, or you take it out of your garage, you are moving on a ramp. So looking at a ramp motion, we can understand it by drawing the forces that are acting. You will see that the vertical forces will be the force of gravity downwards, and the reaction force, which is the normal force, which is perpendicular to the surface. But since this is not horizontal, so therefore the gravitational force will have two components, which will be Ft cos theta and Ft sin theta. So the normal component of the force will balance and cancel out this Ft cos theta, and therefore there is no motion in this direction. Whereas along the ramp, again, there will be two forces. One, since the body is moving downwards, so you will have a force Fg sin theta downwards, and you will have a static frictional force in the opposite direction. So when we balance these forces and we say that the body is going to move downwards, then according to Newton's second law, we can apply these F is equal to ma, and we will get the forces Fs minus mg sine theta is equal to ma com. A com is the acceleration of the center of mass. The center of mass here is this dot. So all the forces are acting on this dot. Okay. So we can use this and we can then simplify it. And we also know that since this is a rotational motion, therefore there is a torque. Okay, so tau is equal to r perpendicular multiplied by f, the moment arm multiplied by f. And the frictional force has a moment arm r as well. So the frictional force is acting perpendicular to the radius here. Okay. So therefore RFS is the torque, and instead of F we will now write RFS. So torque, this Newton's second law for rotational motion, like for linear motion it was F is equal to ma. For rotational motion it is tau is equal to I alpha. Okay, so you're going to write RFS is equal to I com multiplied by alpha. Okay. And there you can substitute the values for these and you can get this formula. Okay, so this will be the formula for acceleration of this body when it is on an inclined plane or on a ramp. Okay, what is a yo-yo? You're all familiar with a yo-yo, yeah, right? So one example I gave you was of a top. A top is a very nice little toy that every child has played with, right? Even as adults, we like it. And similarly, a yo-yo is a very simple toy. We all have fun. Even now, we can play with it. As children, also we play with it. And it's a very simple and cheap and toy that demonstrates the concept of rotational motion. So you know what a yo-yo is, है ना? Bolo?
Yes, ma'am.
Yes,
Yes, ma'am.
Yes, ma'am.
it's a small balloon or a small ball, normally with air or water inside, and you can bounce it up and down with the help of one string. Okay, that's called a yo-yo. So a yo-yo, in this case, the forces are acting here on the axle of rotation. And in this case, with the string, when you're pulling it with the string, there's a tension force in the string, and the opposite force is the gravitational force. Now, R naught is the radius of this axle around which the string is wound, and capital R is the radius of the total body of the yo-yo, right? Now in this case again we can apply this formula that we studied in the last case. The only difference in this case is in the last equation there was g sine theta. In this case theta is 90 degrees. Okay, because the body, the yo-yo, rolls down the string at an angle of theta is equal to 90 degrees with the horizontal. So therefore, if you put 90 degrees sine theta, sine 90 becomes equal to 1. And therefore, you have g here. So previously you had g sine theta. Now you have just g. And the rest of the formula remains the same. Okay. So this is an example of rotational motion. Again, torque, I started with this definition at the beginning. Torque is a cross product. Since these are vector quantities, all this is a cross product. So therefore, it has a direction. Okay, so you can write torque is equal to R cross F, or you can write torque is equal to RF sine theta, or you can write, if you write torque is equal to R perpendicular component into F. So perpendicular component will be R sine theta, or you can also take the perpendicular component of the force. So one of them has to be perpendicular, right? Okay, and now here there's an explanation of how you can draw a figure and determine the perpendicular component. You know, either you can take force and split it into its perpendicular components, and then the component of the force that is perpendicular to R is this one. Okay, this one. Or the second case is you can split R into its components, and then the component of R that is perpendicular to F is this one. So you have to use one of these. Okay. And here you have the formulas. Either it's the perpendicular component of force or it's the perpendicular component of R. The important thing is that you should take the component that are perpendicular to each other, whether you take it for the moment arm or you take it for the force. Okay. So this is what I started the chapter with, and this is something we studied in the last chapter as well. So please don't be scared by the number of the chapter. Rather, look at the concept. The concept is the same. This is the same concept that we studied in the last chapter. But now we are explaining the same concept in different ways in order to strengthen your understanding of this topic. And also we are giving you different examples to explain this and again improve your understanding of the topic. Is that clear? And then we discuss different examples and different problems of how to use this. Is that right? So we are using all the concepts.
Yes, ma'am.
So therefore, this is not a strange or new topic for you. This is something you've been studying repeatedly, starting from the time when you started studying physics in metric or O levels, whatever you did. And then coming again to from the previous chapters, again, we studied torque several times, and now we are again doing the same thing. Okay. Most of the formulas we're talking about today are from the previous chapters, right? ठीक है ना?
Yes, ma'am.
हाँ, तो therefore आपने ये नहीं घबराना कि चैप्टर नंबर नया शुरू हो गया है या it's the concept that's important. तो concept वही चल रहे हैं, ठीक है? सही है?
Yes, ma'am.
Good. Okay, so angular momentum. We talked about momentum last time. So what is momentum? What is momentum? अच्छा सोचो और मैं आपकी अटेंडेंस लेती हूँ. Okay. So let's see. Today is the 21st December 2020. And let's see. Sarmat, Amar, Abu Bakr. Abu Bakr is not there. Fatma Babar is not there. Usman Bajwa is not there. Adnam Basharat is not there. Bilal Muhammad is not there. Okay. Hamza Dar.
Yes, ma'am.
Fariduddin.
Yes, ma'am.
Kessler. Kessler is not there. Zaresh.
Yes, ma'am.
Okay. Haris.
Present, ma'am.
Muaz.
Yes, ma'am.
Good. Hafiz Ibrahim.
Present, ma'am.
Good. Humayr Shah. She's not here. Alina. Alina.
Present, ma'am.
Beta bola karo na.
Present, ma'am.
Good. Hunain is not.
Ma'am, wo internet connection.
Acha, Hunain is not here. Rana Shehbaz.
Present, ma'am.
Good. Sania.
Present, ma'am.
Good. Arisha. Arisha is not here. Okay. Chand Kushi.
Present, ma'am.
Okay. Maiza. Maiza is not here. Yusuf Patras is not here. Abira.
Present, ma'am.
Good. Okay. Nadia Mukhtar is not here. Hayan is not here. Cheryl.
Present, ma'am.
Good. Ashreb is not here. Huda Zahoor is not here. Amelia.
Present, ma'am.
Good. Bisma. मोहम्मद बिलाल अब एंटर हो रहा है अटेंडेंस लगाने के लिए. Come on. Bisma. Bisma is not here. Okay, let's see. Sadiqullah is not here. Sohaib.
मैम इधर
Sohaib.
ही हूँ इधर.
इधर
Yes,
वो
ma'am,
बोलो ना. Talha is not here. Zulkarnain Ali, he is not here. ठीक है. मोहम्मद बिलाल.
यस मैम.
बेटा आप अटेंडेंस लगाने आए हो?
नहीं मैम, वो ना मैं पहले हॉस्टल था तो आज घर आया हूँ, तो आज इंटरनेट का काफी ज्यादा इशू था.
तो बेटा आप इंटरनेट आप लोग सारा दिन यूज करते हो इन डिफरेंट वेज, तो यू कैन गेट अ स्मॉल पैकेज, है ना?
नहीं मैम, मैं इसी वजह से हॉस्टल रुका हुआ था ताकि क्लासेस इजी से ले सकूं, तो मैं कल ही आया हूँ, तो आज फर्स्ट डे था,
अच्छा
तो
ठीक
इसी वजह से इतना हुआ, तो कल से नहीं होगा।
चलो ग्रेट। ओके आपने पढ़ना है अच्छी तरह से, राइट?
यस मैम।
Great. Okay, so I left you with a question. I would now like someone to answer that question. What is momentum? Just a simple question. Momentum is, कौन बताएगा?
Ma'am, Ibrahim Irfan.
हाँ जी बताओ।
Yes, ma'am. Basically, momentum is a quantity of motion in body.
The formula is
P is equal to mv,
very good.
mass into velocity.
Very good. So P is equal to mv is the equation for linear momentum. ठीक हो गया? And it is a vector quantity or a scalar quantity?
Ma'am, vector quantity.
Why?
Because, ma'am, velocity is a vector quantity because it had direction.
Very good, very good. So momentum is an example of, for example, why a truck colliding with a bicycle causes more damage than, let's say, a bicycle colliding with a bicycle. है ना? क्या फर्क होता है उनमें? मोमेंटम का फर्क होता है ना? राइट? ज्यादा डैमेज क्यों होता है? है ना? समझ आती है ना? इसी तरह से why a fast body colliding causes more damage as compared to a slow velocity body, है ना? दोनों चीजें मैटर करती, mass भी and velocity. And this is an example of linear momentum. But now we are talking about angular momentum. Just like in linear motion we have a momentum, in angular or circular or rotational motion also we have momentum, and the symbol for this is L. So it's again a vector quantity, and everything you will notice in rotational, angular, circular motion depends upon R, the distance of the circular path from the axis of rotation to the point on the circumference. So R is this vector, the radius, and then again it has a direction normally towards the center, and then you have a cross product, just like you had V is equal to omega R, you have A is equal to alpha R, you have L is equal to R cross P. But the difference in this case is that it's not a simple product, but it's a cross product. And you know that a cross product is solved, you have to change it into a sine of the angle between these quantities, right? And then if you substitute the value of P is equal to mv, you can write it like this. So it's very simple, it's the same concept. The only difference now is that you have to multiply it by R, and the symbol becomes L. Okay, again in this case we look at R and P, you have to resolve them into perpendicular components just like we did for the torque, and you will see that you have to multiply. That's why you have the sine theta component, right? When you open this equation, you get this is equal to RMV multiplied by sine theta or phi, whatever you symbol you choose to represent the angle between the two quantities. Is that clear? ठीक है? सही है? So therefore, just like the torque, in the,
Yes, ma'am.
in the case of torque, we wrote that this is R perpendicular multiplied by F, the perpendicular component of R multiplied by F, or we can write it as R multiplied by the perpendicular component of the force. Similarly, the angular momentum can be written as a product of R multiplied by the perpendicular component of P, or R perpendicular multiplied by P. So one of them has to be the perpendicular component. Okay, so the sign, that's how we, so these are similar, very similar explanations. Okay, Newton's second law. Again, we've been studying Newton's second law from the beginning of this course, and you're all familiar with it. The very simplest form of this law is F is equal to ma. But then we also know it can be written as dp over dt, because we know that P is equal to mv, and therefore P is equal to what? This is equal to, if we differentiate V, so dp over dt will be equal to m into dv over dt, right? So dv over dt is equal to a. So instead of ma, we can write dp over dt. So we get this expression, right? And then similarly, the torque can be written as, like in linear motion, you have F is equal to dp over dt. In circular motion, you replace F by torque, okay? and you replace the linear momentum P by the angular momentum L, and you have the same form of the Newton's second law of motion. Okay, याद रखना आसान है ना? They're all concepts relating to one another. They're all similar. They're all based on what you already know, है ना? समझ के पढ़ो तो और practice करो तो it's interesting and it's not difficult. ठीक है? So again, I'm not doing these derivations for you because you can study them if you're interested or for curiosity, but then I will not give you derivations in the exam. So that's why I'm not spending too much time on this. I'm spending more time on helping you understand the concepts and then to use them to solve problems. Okay. Again, the concept of, we always started with an explanation of every concept related to a single particle. So most of the work we were doing in the previous chapters, we considered every body, whether it's a car or a bicycle or a person or a ball, as a single particle. But now we are becoming more accurate in our explanation, and we are saying that every body is composed of a number of particles, right? So therefore it's called a system of particles. And the same concept like we had in the last chapters, what will be the difference? The difference will be that you will add each quantity for each of the particles. So let us say the total number of particles is n. So you start with particle 1, particle 2, up to particle n. You find whatever quantity you're looking for. Let's say if it's angular momentum, for particle 1 will be L1, for particle 2 will be L2, and so on up to Ln. And therefore, the total angular momentum will be a sum of all these angular momentum, and the symbol becomes capital L. So small l is used for one particle, and then capital L is the whole sum, which can be represented by this summation sign. Okay, and then you can write the formula for the total angular momentum of the system, and you can write it in terms of L, and you can also write it in terms of tau, and therefore you get this equation like we've just written it. ठीक है? Okay, now this table is very important and it's very useful and it's very interesting. In this table, you can see a comparison of translational. Translational की समझ आ गई ना? Translational is linear, straight line motion, है ना? Rotational is circular, angular motion. ये alternately ये terms use होती हैं. Translational की जगह you can also call it linear. Rotational की जगह you can also call it angular or circular. Okay? A motion about an axis, and this is a motion in a from point A to point B in a line. So the quantities that you are already familiar with, in translational motion we talk about force, in rotational motion we talk about torque, and these are the formulas how they are related to each other. In translational motion we talk about linear momentum P. In rotational motion we talk about angular momentum L. In translational motion, when we talk about a system of particles, then we represent it by capital P equal to the summation of the quantity for all particles. And we do the same for angular momentum. Okay. Well, similarly, we can write it in terms of the center of mass of the system in both cases. Similarly, we can define Newton's laws as we've already done above, and also in the last chapters, we can write them for linear motion as well as for circular motion. And then the conservation laws are also based on the same concept for linear motion and for rotational motion, which means for linear motion, the linear momentum is constant. The sum of all the momentum of the body before a collision is equal to the sum after collision, and the same holds for angular or rotational motion. So these tables are important and they will help you solve the problems as well. So you can see different examples. This is a hoop, this is a Ferris wheel. You know that when you go to rides in amusement parks, these are all based on principles of physics. When designing these rides, physics has to be taken into account to understand the motion and then to ensure safety for the people on that ride. So conservation of angular momentum is the net means the total angular momentum at some point ti, initial time, a starting point, is equal to the net angular momentum at some later time tf. So Li is equal to Lf. So we had conservation of energy. We studied the conservation of energy before. We've studied the conservation of linear momentum, and this is the conservation of angular momentum. The concept is similar. Okay, now you can see different examples of how this works, right? These are different examples. For example, when you open your arms and when you close your arms, what happens? and this has an effect on your rotational velocity. Okay, so you can look at these examples. Also, when, for example, when you're diving, a diver has to be very well aware of the position of the arms and the legs, because this will determine the center of mass, which will determine how the diver can safely dive. Okay, and also you can notice that this path is a parabolic path that we've already been studying. Similarly, long jump, an example of long jump, also the position of the legs and the arms at different times is very important to determine how you can increase this distance. You can jump at a longer distance, also you land safely. So these are many examples. This is an example of rotational motion as well. Okay, so these are different examples you can look at. And now we come to the topic of precision and gyroscope. So have you heard of this before? Hello?
No, ma'am.
Acha, a gyroscope is a body, okay, that is used normally. It's a concept, it's a device that is used for navigation, for determining orientation in an aeroplane or in spacecrafts, or you can even use it in your phones, for example. So in this case, you have a non-spinning gyroscope and you can have a spinning gyroscope. So in this case, you will see that the axis of rotation of the body will show the rotational axis, and this will determine your direction of rotation. So I can share a video with you to explain this concept. Okay, so I am going to share a video with you. Okay.
Okay, ma'am.
Okay, so I am going to share this. Let's see if you can see it. Okay, share. So can you see this?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
If we have a rotating object, we say that it has what we call angular momentum. We can represent the angular momentum with an arrow. The direction of the arrow indicates the axis of rotation. The length of the arrow represents the strength of the angular momentum. If we apply forces to increase or decrease the rotation, we say that we are applying a torque on the object. The torque can also be represented with an arrow. The direction of the arrow indicates the axis around which the torque is trying to rotate the object. The length of the arrow indicates the strength of the torque. The arrow for the torque indicates how quickly the arrow for the angular momentum is changing with time. But what if we apply a force causing the object to rotate in a different direction than the one in which the object is already rotating? The torque arrow will be along the axis that the force is trying to rotate the object. The angular momentum arrow will change based on the direction in which the torque arrow is pointing. This means that after the torque is applied, the new angular momentum arrow will now be pointed in this direction.
Okay, hi. So I will share this link with you. ठीक है? Is that okay?
Yes, ma'am.
Okay. So then you can watch it, and also you can study this from the chapter. And meanwhile, your homework will be to study and prepare for homework 3. Okay?
Okay, ma'am.
And again, as I told you, you can study regularly, let's say 3 days a week for your theory paper, and 1 day a week for your practical paper. So do it regularly and then it will be easy. But don't try to cram it over one night or over one weekend, then you will not be able to understand it. So you need study and practice. So you need to practice the concepts that you have studied. So this is homework 3. As I told you before, this is topics 6, 7, and 8. So these are topics 6, 7, and 8. But the chapter numbers are different. Okay, these correspond. You have the course outline. You can compare it with that. So these are chapter numbers. 6, 7, and 8 correspond to chapters what? 7, 8, 9, 10, 11. 7 to 11. Okay, so these are chapters 7, 8, 9, 10, 11. Okay, so this is your homework. Okay, so do it regularly, and you can see that the concepts are overlapping in these chapters. They are being repeated several times. So it's not a matter of numbers, it's a matter of the concept that's important. Is that clear? ठीक है?
Yes, ma'am.
So please study regularly. It's a very interesting course, and but it's not something you can memorize or you can cram. ठीक है ना? So therefore regular study is important. This is why I have been giving you regular updates on how to do this and how to practice this, and also you have the assessment schedule. You can see your deadlines as well. So again, you can divide the number of let's say chapters and the number of days and see how you can prepare this. Okay, is that clear?
Yes, ma'am. Yes, ma'am.
Okay, so your homework, this is your homework for today, and please regularly practice. And you know that I'm uploading the recordings on YouTube, so you can also watch again from there. Is that right?
Yes, ma'am.
Okay, great.
Excuse me, ma'am, Rana Shehbaz.
Yes.
मैम आपने कहा था वो मिड का मैं रिव्यू ऑन कर दूंगी मूडल पे, वो काइंडली ऑन कर दिएगा ताकि हम उसे चेक कर सकें.
उसमें 2-3 बच्चों का इशू चल रहा है who did not follow the instructions, तो उसकी वजह से you know, but don't worry, अभी हम वो वाले topics, different topics पढ़ रहे हैं, ठीक है? So therefore अभी final के point of view से आपका final exam होना है ना, तो I will in fact explain and discuss the midterm exam in class, okay, in one of the classes of the coming classes. But I want to resolve the issue of these 2 students who have had not followed the instructions. So मैं उनको पहले से answers नहीं देना चाह रही. ठीक है?
चलो ठीक है मैम, thank you.
Okay, take care. Bye.
Allah Hafiz ma'am. Goodbye.
Take care, ma'am.
Okay.
Thank you, ma'am.
Thank you.